All right, we're going to take a look at how the shell method works for some problems. So we're going to find the volume of the solid of revolution formed by revolving the region bounded by y equals x minus x cubed and the x-axis from 0 to 1 about the y-axis. Now you can use Desmos to get a good picture of what this is going to look like. That's totally fine. So I've already got the function here. This is the x minus x cubed, and we're revolving around the y-axis. Okay, so if you can kind of think about this revolution, so it's going to come this way and then be kind of circular in shape because you're revolving that. That was not fantastic. Okay, so then, yeah, so kind of a donut-ish shape, except it does not have a actual hole through it. Okay. All right, so we want to think of putting cylinders into this. Okay, so the cylinders, the axis of revolution goes straight through the middle of the cylinder. So I'm going to draw one of them right here. Okay, that's just an example of what one of the cylinders would look like. And remember, there's infinitely many. So there's like a little one here and bigger one out here. And we're just nesting all of those cylinders with each other till eventually it makes this solid. But I only want to look at the one of them, just that one. All right, now the thickness of the cylinder, right there, the thickness is in the x direction. So our thickness is going to be dx. So when we set up this formula, it needs to be in terms of x's. So remember that shell method is 2 pi, and then the integral of our radius, we used p of x, doesn't really matter, times the height, dx. That's the thickness. All right, so let's see what that means in terms of this actual problem. All right, so we're going from 0 to 1. They told us that right here in the problem. 0 to 1. P of x is the radius. So if I take a look at this cylinder that I created, if I want the radius of that, that radius is determined by whatever x value I'm at. So it's just x. And then the height right here, that's determined by the function. So x minus x cubed. And that's it. That's the setup. So now we just need to finish out our integration. So this is going to be 2 pi. I'm going to go ahead and FOIL or distribute that. So we have x squared minus x to the 4th. So 2 pi, we're going to take the antiderivative, and we get 1/3 x cubed minus 1/5 x to the 5th. We're evaluating from 0 to 1. So that will give us 1/3 minus 1/5. That's when we plug in 1. When we plug in 0, we just get 0, so that doesn't matter. So we get 2 pi. 1/3 minus 1/5 is going to be 2/15. So our final answer will be 4 pi over 15. And that is the volume of that solid. All right, let's take a look at another one. We want to find the volume of a solid of revolution formed by revolving the region bounded by x equals e to the negative y squared and the y-axis just from 0 to 1 about the x-axis. Now, clearly we need to use Desmos to graph that. We have no idea what that looks like. So it looks like this. It's a little bell curve, but it's inverted, I guess, from what we're used to seeing. And we don't want all of this. We only want it from 0 to 1, which cuts it off about here, I guess. Okay, so it's this region. Let me fill that in. All right. So this region, and we are going to revolve it about the x-axis, so here. And let me get rid of this because we don't need the rest of that. Okay, so we're taking this region and we're revolving it here. So it's also going to be down here, and then it's this solid. All right, so we are going to think about cylinders being nested in there. So the cylinders go, that the axis goes right through the middle of the cylinder. That's what it looks like. And I want you to imagine just infinitely many cylinders just nested in each other. Now, we want to think about the width of that cylinder. That is in the y direction. Okay, so this is going to be a dy, or you can also think of it, it's a horizontal axis. So we need to have dy's. So our volume using the shell method is 2 pi of our integral. We need the radius in terms of y, and then times the height, also in terms of y. Dy. All right, so let's get some specifics in here. 2 pi. We already know that it's from 0 to 1. They told us that in the problem. P of y, that's the radius. So we need to think about this cylinder and think about its radius here. Well, that is just determined by y, whatever we're at. So the radius is just y. And then the height, that's determined by the function. So the height is going to be e to the negative y squared dy. And that's the integral that we've set up that we'll need to evaluate. So this is the hard part. You'll notice that often that radius is just x or y. That is very often, unless you start rotating around lines that are not the x or y axis. We'll deal with that later. All right, so we want to integrate this. This is going to be a u substitution problem. We're going to let u be negative y squared, which makes du negative 2y dy, and we'll divide by negative 2. All right, so when we make that substitution, I'm going to go ahead and change these to u values as well. So we're going to go from 0. When I plug in 1, I get negative 1. E to the u, and then we have du over negative 2. All right, so we're going to pull that negative 1/2 out. Which of course those will cancel. Now, one thing I want you to notice, we have this negative pi on the outside, and then we're going from 0 to negative 1, usually the smaller numbers on the bottom. So we're allowed to switch that. We're allowed to go from negative 1 to 0. What that does is it changes the sign of the whole thing. So instead of negative pi, we'll just have positive pi. And then e to the u du. All right, so the pi is still out there. We'll leave that alone. Antiderivative of e to the u is just e to the u, and we're evaluating from negative 1 to 0. So that gives us pi times e to the 0 minus e to the negative 1, which will be pi times e to the 0 is 1. E to the negative 1, I'm just going to write as 1 over e, and there's my answer. It's the exact value if you plug it in your calculator. 1.986, and that will work as well. Now, to answer your question that I know you have, why do we have to learn another method? Okay, I mean, we learned the disk and washer method really well. Hopefully that went really well for you in 7.2. Why do we need to learn the shell method? Well, let's try and look at this same problem. Okay, this is the exact same problem that we just did, and let's try and use the disk method. So if we were to use the disk method for this, we would need to slice our disks perpendicular. So they would need to slice this way. And those they have a width in the x direction. So if we were to do disk method on this, it has to be in dx. So our volume would be, remember, disk method is pi and then whatever our function for the radius in terms of x squared dx. So that's what we would need to do. So remember this function, what was this function? X equals e to the negative y squared. All right, so in order to find the radius of this thing, the radius is determined by the function, which we have here, but we need to solve it for y. Okay, so that way we have everything in terms of x's. So let's do that. Let's solve this for y. I'm going to take the natural log of both sides, so I can bring this down in front. So I have the natural log of x equals negative y squared natural log of e, which that'll cancel. I'm going to multiply both sides by negative 1. And then I'm going to this is a -1. I'm going to pop this up here using my properties of logarithms. So this is natural log of x to the -1, which I can rewrite as natural log of 1 over x. And finally, I'm going to take the square root of both sides. So I get plus or minus the square root of natural log of 1 over x. So that's my function for the radius that we would need to plug in here. And you see that this is just kind of a mess. I mean, it's okay, but then we would have to find the antiderivative of that. So the reason for the shell method is because it's a lot easier sometimes. It depends on the problem, actually. For some problems, it's easier to use the disk method, and for some problems, it's easier to use the shell method. So it's important to have both those tools so that you can use the appropriate one at the appropriate time.